Hey everyone, welcome back to the TheQCEGuy, and today I'm going to be covering through conditional probability, and the last thing after this will be independent probability. However, that will come through in a separate video. Sorry for the lack of audio from the past couple videos, and I've been working hard all afternoon to try and resolve that, so hopefully it is satisfactory to you guys. Without further ado, let's get a roll on. So we have recognizing conditional probability, the formula and simple calculations for it, multiplication probabilities, and tree diagrams continued. So recognizing conditional probability, what you want to do is, so conditional probability will mean that it has one event that will depend on the other event occurring. For example, let's go the pokies, right? Your chance of hitting a mega jackpot increases every time that you don't hit any form of winning. So it's like you hit the mega jackpot on like spin 2, given that no one has hit the jackpot for the past 35 turns or whatever it is. Conditional probability is often written as probability of A given B, so we'll have a vertical line in it. Or if it's in a word question, it might be like event given event 2 or whatever it is. And that will mean that event A occurs given B does first. So event B will occur first and then event A will follow through. For the word questions that are a little bit more complicated, you might see if and then statements, or given that and then the probability of the other event occurring is whatever. But normally you'll see if and then statements if they're asking for conditional. And the events are typically said to be dependent for conditional probability. That means that the probability after you calculate the conditional probability will be different to probability of B in the case of B given A, or different to probability A in the case of A given B. I'll explain that briefly, but should be a little bit beyond the scope for now. So the use of the formula probability of A given B, it's not particularly useful, but I will show you a question where it comes into use on the next slide. But let's run through the basics real quick. So probability of A given B, you will often see written as like that, right? And in order to determine it, you have the intersect of A and B. If you remember the intersect, it means like that middle part of the Venn diagram. And you're going to divide that by B. And so how I imagine this question is, you treat that vertical line like a division bar, right? And you also treat it like an n bar. So it's A and B, divide B. Or if that was the other way around, B was there and A is there, it would be B intersect A, divide by A. So whatever letter is last, you divide by, and then the top part of the fraction you multiply by. Or you solve for A and B, or you use the value that's given to you. Okay, I've got an example question here for you. So the table shows the results of 100 people aged between 16 and 29 about their preferred choice of food when eating at a cafe, that being vegetarian or non-vegetarian options. So the probability of male and vegetarian, right? So in order to determine A, or male intersect vegetarian, what you should do is you look for male, okay? Males are these two. Now which one has V? This one, 18, okay? So 18 is a good start. And now you divide that by the total number of people. So 100. Boom. Okay, B, male given vegetarian. So what that means is that you need to look for male intersect vegetarian, divide by vegetarian, which would look like 18. That's where we got that M intersect V from. And then you're going to divide that by vegetarians. So in order to determine the amount of vegetarians, you sum together these amounts and then you'll get that number down the bottom, 43. 18 over 43 is your answer for B. C is similar, quite straightforward. Not V given F. So you're going to look for not V, intersect F over F. So not vegetarian and female. Not vegetarians over here, female, so 19. And then you're going to divide that by total number of females. 25, 19 is 44. 19 over 44 is your answer for that. And lastly, probability of V you can get by that sum there, so that's just 43 over 100. Okay, multiplication of probability. So, probability of A intersect B can also be determined with this method if they are both independent or dependent. So, probability of A intersect B can equal the probability of A given B times the probability of B. And that's just by like rearrangement. But all you have to do is just keep that in mind and how that works. And you should be fine for like pretty much most of the questions you do. So, B given A times probability A, or A given B times probability B. So whatever letter is last you multiply by, and that will give you your intersect. So here I have a good example. Probability A equals 0.6, probability A given B 0.6125, and probability of not B is 0.2. Calculate probability of A intersect B and probability of B given A. Let's do A intersect B first. So, you can see that this formula here can be used, right? So probability of A given B is 0.6125, so we're going to get that number, 0.6125, and we're going to multiply this number by the probability of B. In this case, that's B naught is 0.2, so probability of B is going to be 0.8. And now that number, allow me to grab my calculator, but that number should be within the realms of like 0.48 something. 0.6125 times 0.8, 0.49. Okay, and now probability of B given A means that you need the intersect of A intersect B, and you need to divide that by the probability of A, which we have here. So now you have your A intersect B as 0.49, right? And then you plug in 0.49 over probability A. Probability A equals 0.6, and that will equal 0.49 over 0.6, 0.816 with the 6 recurring. So yeah, that's kind of like where you'll use this formula. If you're given A given B and you need to calculate A intersect B, it will be pretty useful to use it there. Next up, we have the tree diagram. So this is one of the harder questions that you'll get given, but I might as well show you it now. So a box of chocolates contains 6 soft-centered and 4 hard-centered chocolates. A chocolate is selected at random, and once eaten, a second chocolate is chosen. Let SI be the event. So this SI and HI part is meant to confuse you, but pretty much what that's saying is like whatever that number is in like little script next to it is the draw. So what this like part A is asking you, deduce the value of the probability of getting a hard second and a soft first given a hard second given the soft one first, which would be H2 intersect S1 divided by S1. So H2 intersect S1 will look like, okay, there are 4 hard center chocolates and 6 soft center, right? What I might do is I might draw a probability tree. So you have hard, soft, hard, soft, hard, soft. Now, there are 6 soft originally out of 10, and there are 4 hard ones. If you pick a hard one, then there's going to be 3 left, and you've removed 1, so 9. 3 over 9. And if you pick a soft one, there's going to be 6 left over 9. Over here, you've picked a soft one, so there's going to be 5 over 9. and 4 over 9. So now what you can do is you can determine H2 intersect S1. Okay, well, H2 and S1, so you're looking at S1 first, then the H over here. Or 6 over 10 times 4 over 9. And then when you solve that, that's going to be divided by the probability of S1. So that means the probability of anything having soft first, which will be soft hard or soft soft. So in this case, it'll be 6 over 10 times 4 over 9 added onto 6 over 10, 4 over 9, added on to 6 over 10, 5 over 9. And then if you get a calculator and you solve that, then you should be able to get 6 times 4 is 24 over 90. And that's going to get divided by, same thing, so that's going to be 24 over 90 down the bottom. And then 6 times 5 is 30, so 30 over 90. 30 over 90 plus 24 over 90 is equal to 54 over 90. And now all you have to do is solve that. So plug that into your calculator, 24 over 90 divided by 54 over 90 is equal to 4 over 9. Sorry for the messy handwriting. This is really hard to write with the touch screen. Alright, probability of C is that the first chocolate has a hard center and the second has a soft center. So you can just use the probability tree for that. And it's like the first chocolate has a hard center, 4 out of 10, and the second chocolate has a soft center, 6 over 9. Multiply them together, kaboom, 24 over 90. And then calculate the probability that either both chocolates have soft or both have hard centers. So soft is 6 times 5, 10 times 9, so 30 over 90, or 1 over 3. And you're going to add 1 over 3 to whatever hard is. 4 over 10, 3 over 9 is 12 over 90. So it'd be 42 over 90 in total. Right. 45 plus 12. Sorry, 57 over 90. Anyways, thank you for tuning into the TheQCEGuy. Sorry for the longer video and that last question being a bit messy with the handwriting and a bit confusing. But I really suggest you guys go have a look at the textbook. They've got heaps of practice questions and I'm sure you'll find it useful. And if you feel like you're struggling, just go through it, try and learn it. Watch the other people online who do stuff, or even go through and read some of the slideshow note points that Sir has taken down. Thank you for tuning in, and I hope you have a wonderful night.